Let's talk about tectonic plates. What are tectonic plates? You're probably familiar with the idea, plates of crust that move around the Earth. But what's really moving these plates around the Earth? Before we explain that, let's talk about how geology has changed over the past few decades. And we really have to look at one man in particular. His name is Alfred Wegener. This is Alfred Wegener, the father of modern geology. He was a German climatologist, geologist, geophysicist, meteorologist, and polar researcher who was born in 1880. And he came up with this idea of continental drift. And he used a few things to explain what continental drift was, which was basically that there was once this large landmass known as Pangaea. Alfred Wegener had a few things to support his idea of a gigantic supercontinent of Pangaea that eventually drifted apart into the continents that we see today. Some things that he used as evidence were things like fossils, where he said the fossils on Africa match fossils found on North America and South America. He used things like rock structures, where he looked at the Appalachian Mountains in North America, and he looked at the mountains over in the western part of Africa, and he said the rocks on these mountains look very similar. He looked at other things like ancient climates, climate conditions found on one continent to the other. He even looked at the magnetic anomalies found in rocks, where he said the iron minerals face kind of the same direction whenever you put these continents together. So he used all of this stuff as evidence. But the geologists at the time kind of laughed at him and told him that he didn't really have a mechanism to provide the idea of continental drifts. Like, all of that was good and all, but how did it happen? He didn't really have the answer of how it happened. He just kind of had the evidence that supported that we once were a supercontinent. So he was kind of pushed off to the side until about 100 years later, after he had died, an idea came up. We learned some new evidence during World War II of kind of this mechanism. Follow along for part 2, talking about plate tectonics and how Alfred Wegener came up with this idea of continental drift, where there was once a supercontinent of Pangaea that got split apart into the continents that we see today. And he didn't have a mechanism to support continental drift until we get to World War II, when we start mapping the ocean floor. When the U.S. government was actually looking for German U-boats, but they found something extraordinary. What the U.S. government discovered was these scars on the ocean floor. As you can see here in the center right of your screen, you see a long vertical line with a bunch of horizontal lines coming away from that long vertical line. And what that is a mid-ocean ridge. And this is actually the mid-Atlantic ridge. And this is what is driving new crust on the Earth. Let's take a closer look down at that mid-ocean ridge. Here's a closer look at that mid-ocean ridge. So you see where it's labeled there, that line, that vertical line going across. You have new crust being created that's being pushed on either side of the ridge. So in the Atlantic example, you have crust that's moving west and you have crust that's moving east. This is brand new crust that's being created, and it's pushing the plates away from each other. It's pushing the plates. It's what's driving the motion of this plate tectonics. But then you say, okay, well, what happens to the other crust? You would think if we just have new crust being created, that we would eventually, that the Earth would just be growing in size. But then we have to look at subduction zones. Here is a subduction zone where you have oceanic crust going under continental crust. The continental crust is overriding the oceanic crust, and that oceanic crust is diving under the continental crust. And so this is the older, more dense crust that's being subducted. And so that crust goes back down into the mantle, and it creates new crust at mid-ocean ridges. And so it's a huge cycle where the crust gets eaten at subduction zones and created at the mid-ocean ridges, and that is the essence of plate tectonics. That's what's driving the plates around the Earth. That's why sometimes they come together to form supercontinents, and sometimes they split apart into like 7 continents that we have today. I hope this 2-part video was a great explanation of plate tectonics.